We're going to calculate or to find the limit as x approaches to infinity or negative infinity of functions that have a square root. This is similar to L'Hopital's rule, just that in L'Hopital's rule is easier if we don't have roots. When we have roots, it comes a little bit complicated, a little bit hairy, so we are going to see in each case when we have roots, square root, and when x approaches to infinity or negative infinity. And here I have used some examples, but at the end of this video you will have idea of how to approach it depending on if it is approaches to positive infinity, negative infinity, or and also you will see that it depends if we have which is the highest degree of the x or the degree of the polynomial. So let's begin. The first one is the limit as x approaches negative infinity of square root of 4 square x minus 3x divided by 4x plus 5. I'm going to read you all of these. Try to find it if you want, or feel free of stop the video in any moment, but just in case I'm going to read them first. The limit as x approaches negative infinity of square root of 16x squared minus 8 square x divided by square x plus 2. Here the limit as x approaches infinity of sorry, here I mistaken this 16x to the 4th power. Now limit as x approaches infinity of 3x minus 1 divided by square root of x squared minus 6. Limit as x approaches negative infinity of x to the 5th plus 4x squared divided by square root of x to the 10th plus 8x to the 7th. Limit as x approaches negative infinity of 9x to the 6th power divided by square root of 9x to the 12th power plus 4x to the 6th power. You will see that the difficult ones would be with negative infinity. As you see here, I only put one with x tending to positive infinity. So I will begin with this one. X approaches positive infinity. So what we will do in anyone would be to divide the whole expression by the same denominator. But here you could divide both. Well, here I will divide the numerator by x, and here I will divide it by root of square x, that is x. So here would be 3x minus 1 divided by x divided by a square root of x squared minus 6 divided by a square root of x squared. So here you have 3 minus 1 over x divided by a square root of 1 minus 6 over x squared. You know, we're taking the limit as x approaches infinity, so 1 over infinity is 0. Here 6 over square infinity, 0. So it approaches to 3 over a square root of 1. So 3 over 1. So this approaches to 3. And we will do the same with each one of these. The issue is that we only care about the highest degree of the x, because the other one, when we divide by a higher power of x, goes to 0. So for that we will only care about the highest degree. And the other thing that we care is we are approaching to infinity or negative infinity. Sometimes it matters, sometimes don't. Let's see here. The limit as x approaches minus infinity of square root of 4x squared minus 3x divided by 4x plus 5. We will divide this one by square x and this one by x. But because we are approaching to negative infinity, we will divide, remember that square root of x, well, the square root could give you a positive or negative value. So we don't know which one, but we want the negative root because we are approaching to negative infinity. So we will divide this instead of just root of x squared, we want the negative root, so will be divided by negative square root of square x. So it would be 4x squared minus 3x divided by minus square root of x, all of this divided by 4x plus 5 divided by x. So here you have 4x squared minus 3x all over x squared. All of this inside the root, and this minus you can put it here. And here you have 4 plus 5 over x. Here you have 4 minus 3 over x. And you know these two go to 0, and you approach to 4, root of 4 divided by 4, but with this minus. So it is minus 2 over 4, so it is minus 1/2. Here the important issue was that we need to divide this not in square root of x, but with minus square root of x, due to we are approaching to negative infinity. Let's take this one. Now we will see that doesn't matter if we approach infinity or negative infinity sometimes, like in this example. Look. In this example, again, we need to divide this by x over x to the 4 and this x squared. And we want the negative here divided by root of x to the 4th power, and this divided by x squared. Now we will take as here the negative root of the square root of x to the 4th power. So let's do this. We have the square root of 16 x to the 4 minus minus 8x squared divided by minus, so I will put the minus here, square root of x to the 4th power, all of this divided by x squared plus 2 divided by x squared. So here, you know, we will just have minus 16x to the root of, here would be just 16, and here would be, well, x squared divided by x to the 4, we would have minus 8 divided by x squared would be 0. And here, x squared divided by x squared is 1 plus 0. So here we are approaching to negative 4. Oh, sorry. I did the mistake that I didn't want you to commit. We are taking the limit as x approaches negative infinity, but remember that the negative root of x to the 4 is x squared, and x squared either be x approaching some positive value or some negative value. X squared would be positive, so the square root of x to the 4 is always a positive number. So here, even though you're taking the negative root of x to the 4, that is x squared, and so you will you don't need to put the negative sign because the negative root is a positive, so you don't need to put the negative. So here it is approaching to 4. Next one. Here, this one. Let's do this one. The limit as x approaches negative infinity of 9 to x to the 6 divided by square root of 9x to the 12 plus 4x to the 6th power. This is, again, we will divide this by x to the 6 and this root of x to the 12, and here we have the same thing. Root of x to the 12th power is x to the 6, even though x is tending to the negative or positive, because the root is x to the 6, x to a even power. So there will not be any negative sign because the root is positive. So here I don't need even to think about it. Here I will just do, this will be 9 divided by square 9 divided by square root of 9, so it would be 9 divided by 3, so this would be 3. And here, this would be the limit as x approaches negative infinity of x to the 5th power plus 4x squared divided by the square root of x to the 10th power plus 8x to the 7th. Here we will divide this by x to the 5th, and here x to the 5th, and here divided by root of x to the 10th power. But here the root of x to the 10th power is x to the 5th, so here it matters if x is tending to a negative or positive number or infinity. So here it matters, so here will be, I will do it just in the brain, you know now how to do it. This would be just 1 divided by minus 1. So this is just minus 1. So the important issue is, first, once you know how to do like L'Hopital's rule, that is, we will divide by the highest degree, and when we have the, or in the denominator or numerator, when we have the root, we divide by the square root of the highest degree. Once you know how to do that, the complicated thing is when we are approaching to negative infinity, to know if we put the negative or positive sign. That is not we put it or not put it. The issue is just if both, well, if the highest degree polynomial that we are approaching inside the root is a x to the even power, even though we're tending to negative infinity, there is no need, well, we should not put the negative because the root will be positive. The negative root will be positive. And if it is x to a, inside the root, x to a some, well, sorry, usually always we have only in these examples I put a square root of x to some even power. Sorry, I mean when this square root of x to that even power, the square root is x to some even power, because the square root is x to some even power, this means that the negative root is a positive number. When the square root of x to that even power is x to some odd power, that's when we care if it's tending to negative or positive infinity.